Welcome back to part 6 on quadratic functions and modeling. We are now going to look at a monopoly market situation where the demand for product is given by 385 minus 0.2x. The fixed costs are 13,500 and variable costs are 40 plus 0.80x dollars per unit, where x is the number of units. If there's one thing you need to keep track of throughout this problem, it's that x represents the number of units. Now, depending on the function we are using, we could be either talking about revenue, which is money we make from selling items. We could be talking about cost, which is how much it takes money-wise to manufacture items. Or we could be talking about profit, which is the difference between revenue and cost. So if you subtract cost from revenue, you will get the amount of profit. This is the most important thing in business. If you're not making profit, you shouldn't be in business. You need to change something, or you need to start a new business, or just work for somebody else. So in this particular situation, when you have a monopoly market, they still want to make a profit, but their profit, revenue, and cost functions are quadratic. So if you want to find the maximum revenue and the number of units to sell to get that maximum revenue, we can use one of two options. We can put r of x in standard form, or we can do something that I personally believe would be a little bit easier. We can use the vertex formula. And that's earlier in the handout, but it is negative b over 2a, comma, f of negative b over 2a. And I'm going to show you how to use the vertex formula because these functions have decimals in them, and so it's not necessarily so easy to put it in standard form. You can totally do it. I've done it before as examples, but you've got to be able to identify when it's better to use one form over the other. And in this case, we're going to use the vertex formula. So I have the function r of x is equal to 385x minus 0.20x squared. My a is equal to negative 0.20 and my b is equal to 385. So x is equal to negative b, so negative 385 all over 2a. So 2 times negative 0.20. If I wanted to find what that is, I can just put that in the calculator. Negative 385 divided by the quantity. Don't forget to put parentheses around your whole denominator. So my x coordinate, the number of units, is to maximize revenue is 962.5. Now let's find r of 962.5. That's going to be 385 times 962.5 minus 0.20 times 962.5 quantity squared. Let's put that in my calculator. I'm going to have 385 times 962.5 minus 0.2 times 962.5 raised to the second power. So this gives me 185,281.25. Okay, so if I want to list the vertex or the maximum, because this is an opening downward parabola, the maximum would be at the point $962.5, comma, and this is a lot to try and fit on here, 185 to 81.25. So the maximum revenue would be $185,281.25. The number of items to get a maximum revenue would be 962.5 items. If we wanted to find the number of units that have to be sold to maximize profit, we would simply use the profit function instead of the revenue function. Our function for profit is P of X equals negative 13,500 plus 345x minus x squared. If I list my coefficients, I have A equals negative 1, B equals 345, and C equals negative 13,500. Given my vertex, x is equal to negative b over 2a, which is equal to negative 345 over 2 times negative 1. And if I simplify that, x is equal to, negative divided by a negative is a positive, so 345 divided by 2. 172.5. The number of items to sell to maximize profit is 172.5. So substantially fewer items. And remember, profit is way more beneficial than revenue. I'll substitute that back into P of X. To find the actual amount of profit I will receive for manufacturing this many items. I'll go ahead and put that in my calculator now. So my profit will be $16,256.25. And that's way better than just a revenue function, because who knows, if you're making 962.5 items, that doesn't necessarily mean that you can pay for your costs with your revenue. Sometimes if you make a huge number of items, you won't necessarily be able to cover your costs because cost gets higher as you increase production. Sometimes, not always. So in this case, our profit is $16,256.25 when we manufacture 172.5 items.